is an Ingress controller, treated like one. We are part of Cloud Native Nordics. There are events happening across Nordics, and CNCF Helsinki is one of those. We are having more than 2,000 members. Is there anyone new here, which is new to the event? Welcome, welcome. And it is nice, we are having more and more members recently, and we are always looking for speakers as well as hosts. So if you have a topic in mind, please comment, tell either of us organizers here, please take your hands off so people know you. And yeah, please reach out to us, or there is a link here, submit a talk proposal if you have any. And as I mentioned, we are also always looking for sponsors for these meetups. If your company is a sponsor, please reach out to us. And these are also other ways that you can reach out to us, as like LinkedIn, all of those work. We are having a non-profit organization which is called Cloud Native Finland. Our mission is to promote cloud native technologies in Finland, and one of the events that we organized last year was, for the first time, was KCD Helsinki, which happened for the first time last year, and it's happening this year as well on May 20th. So I think there are still tickets available. If you haven't registered, buy a ticket. It's a nice event, one-day event. And we have proposals open for posters. If you are a student researcher, you have a topic in mind that is suitable for a poster, please submit. I think the deadline is May 6th. If I'm not wrong, but please check the KCD Helsinki website for more information. What is CNCF? Founded in 2015, has critical components of global technology infrastructure, and brings together top developers and users and vendors that run largest open source developer conferences. This is the structure. There is governing board, which is responsible for marketing and strategy direction. Then we have technical oversight committee, which is the technical governing body for CNCF. It admits and oversees all the projects in CNCF. And there are technical oversight committees, TOC and TAGs and TCGs. TAGs is technical advisory groups, and technical community groups. So basically, technical advisory groups are the ones that decide about the main projects that are happening in CSCF, and those are also sort of a bridge between end user and community. And then the user technical advisory board, which is mostly about end users. There are different hacks, and they usually have meetings. If you are interested to participate, get involved in the community and know more about these tags, here is a list of those, and you can check out their meetings, their information, and participate in any of these activities. And this is a list of technical community groups. There are already 3 of those. Similarly, they have meetings that you can participate and get more information. Already we are done. Good news, we have a raffle happening today. It's for a Go, Rust, Docker, Kubernetes mastery bundle, which is worth of €1,000, and Ardon Labs is sponsoring this. So if you are interested, stay until the end of the event. We will have the raffle at that point, from list of meetup attendees, and I promise to delete organizer names from it. Yeah, we are here. Please reach out if you have any topics in mind, you want to collaborate, you have questions, anything. We are here. And let's have Dennis from CRACI here. Please.
All right, hello everyone. Let's get also Erika's laptop connected so she can start setting up. So, I'm Dennis. I am the co-founder and CTO of CRACI. Thank you to everyone for joining us here today. And I'll also be kind of quickly representing the Founders House because our representatives here are for the Founders House had another kind of overlapping event to attend, so unfortunately they couldn't join today. So a brief intro to the Founders House, so where we are located here, if you haven't heard about it yet. So essentially, started earlier this year. The Founders House is a concept brought from Sweden now to Finland, here Helsinki, where some of the next generation sort of unicorn attempting companies and founders are building. And there's, I guess, around 5 to 10 companies here, as well as a bunch of solo founders currently kind of experimenting and building their new different kind of company ideas, a lot about AI, also us around software supply chain security, different kinds of tooling and ecosystems. And it's also in collaboration with Wave Ventures, who is kind of here as their office as well. So that's the short intro to the Founders House. Now a little bit about CRACI. So we built software supply chain security solutions, essentially to address two needs. The compliance need, so if you've heard about the Cyber Resilience Act or the CRA that is now coming, probably affects quite a lot of you also in the audience. So essentially, there's a new EU mandate for supply chain visibility as well as reporting, stepping into effect this September. We built a platform that automates this end-to-end with a 5-minute setup. And then we also address some of the key sort of both open source and closed source supply chain security challenges that we've seen, especially over the past few months around Axios, LightLM, Shywood, etc., and are able to sort of address this for quite a broad technology stack. So if that sounds interesting, or CRA sounds relevant, or any of this is sort of, you want to chat with us, there's a lot of us here present today. Raise your hands, so kind of more on the back. So feel free to chat with us also after the event. And we're also today sponsoring the food, so feel free to grab some pizza as well as a couple of drinks. And now I'll hand off over to Erika, who's working for CRACI here as a software engineer.
Yes, hello, so my name is Erika Marttinen, and as mentioned, I'm here to talk about software supply chain attack vectors when using generative AI. To get started, I have a small question. How many of you have let an LLM run npm install or pip install or something similar? Yes. This is basically what I expected, and I'm guessing that even if you didn't raise your hands, you probably have coworkers who would do this. I'm personally in this category. And in like many ways, I mean, generative AI tools are here to stay. That's just the reality of it. But they're not maybe the most secure thing out there. But before we dig kind of into the security of these tools, I'm going to gloss over some just basic important terms that we'll need for this talk. So, what is a software supply chain? It's essentially a list of components, libraries, tools, and processes used to develop, build, and publish software artifacts. Essentially, it can be like open source libraries or frameworks or compilers, CI/CD pipelines, whatever you need to like build and deploy and monitor your apps. The software bill of materials, or just SBOM for short, declares like an inventory of components to build some specific software artifact. You can think of it like when you buy something in the grocery store, you have an ingredient list, but instead of saying, yes, it has milk and eggs and whatnot, you list both like open source and also potential internal components that go into your app. SBOMs are useful like also for compliance, like we just heard about the Cyber Resilience Act. There is also an executive order in the USA that requires an SBOM, but they're also like, in addition to being a compliance thing, they're kind of a proactive security tool that helps you like gain a view of what actually goes into your software. And then finally, a supply chain attack is a cyber attack that specifically targets your software supply chain. And for example, if you've added some dependency into your app and then that dependency has a vulnerability, then this may act as a backdoor for some adversarial party to get access to your system. As of now, it actually holds that there's more and more and more supply chain attacks. I'm going to highlight a few that have happened in the past couple of months. These have just been major attacks, but there's of course many more. The first one is Vercel that happened just earlier this month. Vercel is a cloud deployment and hosting platform, and there an employee had signed up to a third-party AI tool called Context AI, and then clicked allow all permissions to their professional Google Enterprise workspace. Maybe not the best idea, and this turned out to not be the best idea because then through this account the attacker had access to a lot of like customer data and private internal data, and there is like word going around that they're like pressuring Vercel for money, but I don't think this has been confirmed. Then last month, Axios, which is I think the most popular JS HTTP client library, was compromised also through the attack of a maintainer this time. Here, using this account, the attacker was able to inject a malicious dependency that had like a post install script, so it was a bit more hidden. And then using this script, the attacker gave remote access to the system, which is fairly rare these days. It's like early days of cybersecurity had this, oh my god, reverse shell. But happens even now. And then in the past months, there have actually been 2 attacks on Trivi, which is ironically a security tool. It's used also like to generate SBOMs, but also like other things. And there, the attacker used stolen personal access tokens to take over the Twitter repository, and then when someone noticed it, an issue was opened, and basically the issue is flooded with a bunch of bot spam. All the comments are from like seemingly real-looking accounts with like a lot of repositories and so on, and they basically all said, wow, this fixes everything. But yeah. Specifically, the second attack is also most likely the backdoor that caused an attack on Light LLM just a bit later, also in March. And they also experienced the same thing of the issue being open and then it was full of just bot spam. But if you look at this list, there is actually only one attack that is confirmed to be like a byproduct of using an AI tool, and even that, like, it doesn't necessarily have to be Gen AI. So, why am I talking about this? It's, but there is actually a connection between like generative AI and supply chain security, because it's not that they introduce any new attacks, but it just kind of instead amplifies the existing risks. So none of the attacks before were maybe because of Gen AI, but the risks are amplified, and that is just a fact. I'm first going to talk a bit about, like, yes, we all know that the AI tools are inherently probabilistic and like not exactly like deterministic with their behavior, but I have a couple examples for that, and then afterwards I'll talk a bit more about specific attack vectors. So let's talk about training data poisoning attacks. As we know, LLMs are deep learning models and are vulnerable to these kinds of attacks, kind of by design. The models are not trained on some carefully handcrafted, beautiful data sets that are like clean, but instead they use a bunch of samples that have been crawled from the internet, often like billions of samples, and then these are called web scale data sets. But also, as a consequence of them being deep learning models, they're like kind of resilient to random noise, which has been then, like, the quantity over quality has been acceptable because like such a big part of it has been good enough. But it actually holds that even small amounts of noise is enough to disturb model behavior. To demonstrate, I here have a paper from Carlini et al. About poisoning these web scale training datasets. They provide quite a cheap way. I think the estimated cost is like $60 to then get like specific targeted mistakes into the models themselves. The first attack exploits the fact that the data says there's no like cryptographic integrity. You just kind of take it and transmit from. And the second one would kind of make changes to public sites like, say, Wikipedia just before the snapshot is made. And this specific attack, okay, the paper is 3 years old, but at the time of publishing, it could crack like all the biggest deep learning models at the time. But this is all like very sciencey. I'm going to give you a more intuitive example. So I was scrolling Mastodon the other day, and I came across this post. It's a screenshot from a Reddit, r/brand new sentence. But basically, someone had posted a screenshot of, I assume, Twitter or X, asking why the Japanese McDonald's hamburgers are a bit like, they're like off-center, kind of. And then someone, a Redditor, hopped in and was like, wow, oh my god, finally, the day comes, someone asks, they give a very like legit looking answer of like, oh, it looks more handcrafted and you don't want this look of it being like too like showroomy and too perfect, and it needs to be in something post-war Japan and blah blah. But at the end, as I've highlighted, they say, just kidding, I don't know, I made that all up. But then, the next day, someone asked Google's AI mode, and you can take a guess on what it cites. It's exactly this thing of like handmaking, and there is no source stating this. Yes. Maybe a bit more like intuitive than the science paper, but this can be explained that most of these like AI overviews get their data from Reddit. This is a study from SEMrush. I think they make this study like almost yearly, and previously Reddit had an even bigger part on this, but yeah, still at number 1. So with this in mind, let's talk a bit about cyber attacks. First, I'm going to talk in more depth about something called dependency confusion attack. So this is like not an AI specific attack or anything, but it's like, say that you have a developer and they like accidentally mistype the name of some tool or package. For example, password manager with 2 A's and password manager with like correctly spelled. This is actually a thing that happened to my friend. He had to change all his passwords. And then another, I guess, more like subtle way of how this can happen, it is if you mix private and public package indices, so you have something pulled from like a public PyPy and then something from a privately hosted PyPy. But have you ever thought about what happens if you have both public and private? Like, what does the package manager do? What does pip install or Ruby's gem install? Which packet does it take? You would think it takes the private, but actually pip install with the extra index URL flag looks at the private package, and then it looks at the public package, and then it takes the one that has the higher version. This is maybe, yeah, and JFrog Artifactory has the same exact behavior. Like in pip, there is a way, like there's another flag called index URL instead of extra index URL, of course, where this like doesn't happen. I don't remember what the solution was for Ruby, but JFrog did not have a way to solve this. This is default behavior. This I found from a blog that I've or like an article that I've also linked below here. It's a very interesting read. The person kind of goes through how first you can find the names of the packages through, like in NPM it's very easy, all right, in JavaScript, and then afterwards kind of there's some small DNS trickery, but other than that, they were able to attack or like hack with permission into systems from Apple, Shopify, PayPal, Netflix, Yelp, and Uber. And I think most of those gave him like a 30K bounty. So yeah, not bad. But there's of course the kind of classic risks of GenAI. This is more things that you've probably heard time and time again. It's like, yeah, there's these dependency confusion attacks, but then it's like, okay, what happens if your tool itself, like your VS Code Copilot plugin or your Code Close CLI or Mistral CLI or whatever you're using, has a like vulnerability, then that may act as a vector to your system. And then it's also common for AI code to be like a bit more insecure. Like there's a lot of API keys posted on GitHub. There's also crawlers for GitHub that get you those API keys. Then it's like common logic flaws. If it's like SQL injection vulnerabilities or similar, or then just giving like too much privilege, because it kind of makes sense if your developing experience is very smooth, even though maybe you should then configure something properly instead. Yeah, then there's also the classic of just prompt injection, so you manipulate the LLM to bypass some safeguards. There's actually in Founders House another startup that specifically studied this prompt injection, like how much does it take for you to basically break one of these models. And I remember talking to one of the founders, and I was like, how difficult is it then actually to, like, if you know what you're doing, to break them? And she just went, oh yeah. So yeah. But if GenAI tools can bypass their own security guardrails, can we even use them in the first place? I'm going to say yes, we can. Because, like I said before, it's not that I talked about any like unique new risks. It's everything's kind of familiar, which means we also have familiar ways of mitigating it. Very convenient. Repetition. I think you all have heard the kind of rules of thumb of how to develop more securely, but repetition is the key to learning. So I will be going through the laundry list of kind of tips on what to keep in mind when you're using, or you have a team that's using Gen AI tools. So supply chain is my favorite. There's supply chain hardening. You should pin your dependencies using some SHA hashes or something equivalent to verify like cryptographic integrity, and also freeze your versions. There's also ways to add deny lists to dependencies that you know are malicious or specific versions. Then it's also important to have secure build environments. So if, say, a developer accidentally pulls in a malicious package or something happens, you can always have the smallest possible blast radius before it escalates into something worse. And it's also a good idea for like CI/CD pipelines that often have a lot of privileges to just have them with least privileged access. There's also existing security frameworks that are good to follow, such as SLSA, or it's pronounced SLSA, that provides you guidelines on what you should do to follow best practices. And then, you can use a tool like SageStore. I also wanted to highlight it here for signing and verifying artifacts. There's also many linkers that have detection of potential insecure attacks, including Git leaks is one for secrets and API keys and stuff. But there's also, I think there's a link for Go that checks for patterns that might be insecure. And of course, code security is also one of the main reasons why we have code reviews in the first place. So yes, it is still important for people to review code. Then another good idea is to maybe limit your LLM capabilities. Of course, you shouldn't trust these tools with your production data, except if you want to lose it. And this is actually a coworker of mine said this, that if you wouldn't trust a random intern with the data, would you really trust an LLM? I maybe wouldn't. Then it might be a good idea to run AI tools in some isolated environments. I personally run mine in a container, but then I've also heard of people running virtual machines to just have the models go ham and see what happens. For LLM interactions, it's consider what permissions we want to give it, and then give it the least possible privilege so that they don't, say, access random data on your machine that you don't want to be shared. Or you can also, if it's really critical, use private or self-hosted models, potentially without internet access, but this is I don't know if there's that many use cases. There's probably some, but yeah. And again, always review your code, configurations, everything. It's important. And then, as this is also a cloud-native meetup, I also have cloud-native best practices. It's good to have GitOps, so Argo CD or Flux, to have a single source of truth, and then you can also more easily verify just the things you actually want to be deployed, that they actually are deployed. You should sign images with cosign, which is a part of SageStore. And here, I've said generate and monitor deployment endpoints using Trivy, but remember Trivy was compromised before, so it also makes sense to always pin the hashes of the tools you're using, not to accidentally bump your Trivy version and then you're cooked, like light LLM. Then you can also restrict permissions with role-based access control in Kubernetes that we're going to hear about later, I think in the next talk. And it's a good idea to enforce network policies, which pods can talk to which other pods. It's also been shown that the best way to have better security is to have better observability, for which OpenTelemetry is a great tool. And there's a tool called Falco with which you can detect anomalies. So if suddenly your API starts blowing up, it's Falco will probably notice it. And if you have a per deployment SBOM, then you can much easily scan it against some known vulnerability databases to maybe see if you have some new zero-day vulnerabilities, because the SBOM doesn't really change if it's per deployment, then it's always constant for that one. Whew, quite a list. But remember, in principle, none of the things I've said in the past 3 slides are inherently new. And this is just good practices in general to have like secure code. So to summarize, we introduced that software supply chain checks are very much present and more every day. We also showed that GenAI tools cannot be made bulletproof, kind of as a consequence of how they function behind the scenes, but they don't really provide, or like, they don't really introduce that many new risks per se. You just have to be aware and keep your kind of hygiene up. And possible threats, even when using GenAI tools, can be minimized with very familiar security best practices. It's been an honor. Thank you for listening. Feel free to connect with me wherever. And do we have any questions? Yes.
Yeah, I have noticed a big change on how attacks are done. So it seems that they are targeting to developers nowadays more often. Is this true or not?
Are you referring to tools like OpenClaw?
No, I developing tools like example was this light LLM. I think it was planting the rootkit on the developing machine, not actual what you are building, but targeting the developer and the building environment.
It's like, of course you could do like a denial of service for your customers, but I mean, arguably it is more annoying to just target the like developer and get kind of more damage out of it, I guess, and maybe like pressure the company for money, like the Vercel case has been rumored to. I have to admit that I have not like followed the security scene for say 5-10 years, so I'm not sure, but you're probably right that there is this kind of a trend.
Actually, I'm not sure, but some highlights are look like that, and I wondering that do we put enough attention to the actual workstations, because it seems to be pretty wild what people are doing nowadays.
Yes, and like one thing I didn't really mention in this talk is like how can you use AI for offensive attacks? It's again, you can't really do new attacks. We can very much make them do them more frequently and kind of do more rapidly attacks. So definitely something where like more visibility and being more aware of these becomes increasingly important.
Any more questions?
Yeah.
Yeah, so we were talking about the code reviews.
Yes.
I was wondering. So yeah, we were talking about code reviews, or you were talking about code reviews. What do you think of AI-based automated code reviews? Would you recommend incorporating this into the workflows and like maybe solely relying on them or not?
I personally don't use them, and I also personally have never properly tried to use them. I think there's, like with many AI tools, there's probably value to gain as long as you can do it like securely and just not like blindly trust. Like I'm willing to believe that there's probably a lot to gain from them, but yeah, I haven't personally experienced around with them too much.
I've tried and it's working pretty well, but not as the only thing. Definitely not.
Yeah, since
so in conjunction with it works.
Yeah, so we were talking about now to trust the AI. If you're trusting your train, you don't trust the AI. So I was wondering, since there has been a lot of hype of using AI-based automated code reviews into your workflow. So from that point of view, I was thinking, should we even use them for review, since review is like our, second best place to catch the bugs if we have generated our code using the AI in first place.
Yeah, I think it's like Lucas said, that it's like you shouldn't use an AI review tool instead of a human, if it makes sense. You can use it in addition to.
Yes.
Thank you.
And I can just add, just recently, like 2 weeks ago, state-of-the-art model basically implemented some of the feature in Golang. And then I asked, are you sure? And then after like 2 minutes of like thinking, it said, you know, this if statement never got checked. So I deleted the code. And I just, oh well. This is the code review basically by the LLM itself, which is just produced at the same machine in the same model with the same context. So it's hit and miss sometimes, but it gives a really nice insight sometimes.
Yeah, it does.
Yes.
You need to maximize the token usage.
A company paying for this.
Yes.
And always make no mistakes.
Yeah.
This is what I forgot.
Bro, just a skill issue at the core. No. But jokes aside, I do think there are things to gain, whether it be in coding or code reviews, but being aware and mindful is increasingly important.
Thank you very much. So now there's more pizza waiting for all of you, and then we'll continue, have some networking and continue in maybe half an hour or so.
there was a little bit of internet shadow over this place for some time, but now stuff should be working at least. Is the stream as well? Oh, okay, great. Well, welcome from my side as well, Lucas. Part of organizing this meetup, and I've been working on some stuff or on this stuff for 2 years or something like that, and I've tried to hold off, like presenting anything to, here for some time, but now today with this team, it felt pretty suitable. So just when we started, I wasn't saying hello because we were reviewing this Kubernetes access, Kubernetes enhancement proposal with the other maintainers. So sorry I couldn't miss that. Anyways, right-sized Kubernetes access control, and this will be basically a mesh of 3-4 other talks that I've given in other places recently. So there was one at KubeCon, one at KCD CERN, and another one at KubeCon now recently. And let me summarize those and kind of provide you with some hopefully good context, and then I would be very happy and interested to hear your feedback on this thing. So I've been contributing to Kubernetes for quite a while. Started 10 years ago, but been doing some other stuff in between, like university. But now I'm soon done, so can put more time into these kind of things. And one of the interesting projects that I'm gonna tell you a little bit more about that I just became a maintainer in is CDAR policy as well, an access control engine in CNCF. So we will, as an outline, briefly introduction to what Kubernetes access control does and how it works. Then the enhancement proposal that is being discussed kind of in the project at the moment and is in principle accepted as a feature, and I've implemented it, but now we kind of keep refining it. And then how you could express access control policies for Kubernetes with a project called CDAR and how it fits into this feature, and then what to take from here and where to go. So any type of access control system, you have the kind of tug of war between 4 or 5 conflicting requirements. On one side, you need it to be expressive so that you can do the stuff that you need to. But on the other hand, it needs to be fast. This thing goes through every single hot path that you have. It needs to be safe, because if someone authors you a policy and gives you a policy and says, please execute this, would you take a binary file and execute that server side, in the hot path? Maybe not. So how do you balance that, right? And one of the more less talked about and more kind of interesting features is how do you know what's going on? So like at first it's easy. You have a policy, admins can do admin stuff. Everyone else can do, basic stuff. But after some time, as these rules start, you have them in the tens or hundreds or thousands, and you have tons of groups and whatever. It's really hard to know what's going on. So how can you analyze and make sense of the policies that you have? And if you implement this yourself, you need to make sure that all of this, whatever the solution that satisfies these requirements, are correct. And yeah, it's easier said than done. So if we put this in a Kubernetes context, we have role-based access control. Kind of gives you quite limited expressiveness, but it's fast, it's safe, and analyzable for the most part. Then there's another thing in Kubernetes, we'll dive into this in a bit more, that kind of lets you write some more fine-grained policies for a specific thing called admission in Kubernetes, which we will talk about soon, using a specific language called CEL, Common Expression Language. This is way more expressive, but now you have less kind of idea about what's happening, and also you fell over the analyzability wall, so now you don't have the analyzability really anymore, or at least not in mathematical terms. And what you could do as well is just, like I'll just solve this by, I have my API server, I'll hook out to some random HTTP endpoint and call it a day. and whatever yes, no comes back, I will use that, right? But now you don't know anything about the policy behind the scenes, right? So, and there is this kind of webhook in Kubernetes actually, but you have most likely not used it because it's not configurable in any of the distributions. If you run a kind cluster on your local laptop, you can use this webhook. But if you start, on Amazon, Google, or Azure, or UpCloud, then you wouldn't be able to configure that. For good reason, because it's not fast, it's not safe, and it's not analyzable. That's why. So is there something in between, right? Like, can we put something here? We get more expressiveness, but we still have the benefits of analyzability. That was the kind of, the dream. Let's see if we get there. So to backtrack a little, and for those that might not know, in the Kubernetes request chain, the first thing that happens, or roughly speaking, in the simplified view, is that you authenticate the user. So who is the user? And this you can do in a couple of different ways. For example, using OIDC maybe is the thing that tokens. You single sign on into Google, and then you use that for your Kubernetes cluster as well. That's nice and good, right? Now you have user information. Next one is authorization. So in this case, maybe someone of you have used Kubernetes RBAC, role-based access control, which lets you grant permissions based on who the user is and name and group, and then based on the metadata of the request. So whatever you can extract from the URL, basically, you can authorize on here and say yes or no. Now, if you have a read request, that's all you got. Then it goes to storage, and then whatever comes from storage, is returned. If you have a write request, you have one more phase. And now if you have a write request, you also have a payload, right? So you send a create request, you send a pod or whatever, service account or something like that to Kubernetes. And in Kubernetes you can actually, add a hook to actually check, I got this kind of pod and I got this kind of user. Now, should Lucas be able to do these things with this pod? So like, should I be able to use root containers, right? Maybe not. Or if I'm an, like in the previous talk, an AI agent, should I be able to, use privileged everywhere and, extract my way into the host? Maybe not. So, but how do you enforce that? Like the first one cannot, because that one doesn't see the object. The second one does, but only for write requests. So, and this is called admission control. And here is the cell which stands for Common Expression Language, which you can use. So for the validating admission control, the kind of third phase there, you have two modes basically. You can do a webhook, and the webhook does whatever, or you write this Common Expression Language rules, which kind of look like, any other expression language, I guess. You can write this, send them to Kubernetes, and Kubernetes will enforce them. So that's great. But there's one problem with this. And because you have these two separate, so cell is great, but if you wanted to do something like say, Lucas can only create a pod with this service count, or Lucas can only create non-root containers or something like that, first I need to give too much permission in the first phase, right? So in the RBAC phase, I would say, Lucas, and now I had gateways here. Lucas can create, update, delete gateways. And now the first phase doesn't know about the object, so it just treats it as for any object. Then the second phase, you need to remember, Lucas shouldn't actually be able to do this much, right? Like we need to add this one to remove his permission for the most part and only allow this small fraction. But this is negative logic. So here you have positive only logic, and here you have negative only logic, which makes it kind of hard. You need to add one in one order. You need to add the deny rule first, then add the allow rule, but you need to remove them in the opposite order, stuff like that. And even as I was writing this example, I made one or two mistakes. And I only caught it an hour later. So even as I knew exactly what I was gonna prove a point, I actually confused myself. And what if we could just say exactly what we wanted and not have to deal with both of these modes? So that was my master's thesis, basically, which I wrote a year ago. And that now turned into a Kubernetes enhancement proposal. So in one picture, right? Like what is an enhancement proposal about? Well, Kubernetes asks the authorizer internally, is this whatever request is coming in, say it's a pod, is this, can Lucas create a pod? And then before we had only yes and no, but now we add a maybe, right? So in order to, just make things more confusing. Now, then the authorizer could now say, it depends, only if and the condition, right? So only if Lucas, like actually submits a pod with this specific field, or, only safe things, or, like similar conditions, right? So what could be example use cases? Well, if you have secrets, maybe as I was saying in the first place, you can only say, basically with normal Kubernetes RBAC, you can only say, I grant you all the secrets, a specific, kind of get to a specific set of secrets, or just, everything in the namespace or everything in the cluster, right? So that's the level of granularity you have. But now you could say, for example, that, Lucas should be able to see all the secrets, but not TLS secrets. Or, like Lucas maybe should only see TLS secrets. If I'm an Ingress controller that should, take network connections to the cluster, maybe I should only see the TLS secrets and some of them that are tagged with some, these I should be visible to the Ingress controller type of thing, which is actually, I guess, a great way to segue to the next talk. Or maybe I should only be able to perform updates when I don't change some certain fields, right? So what if I want to, like update an object, but not everything, right? Like that's kind of tricky. Kubernetes actually has some workaround for this, but it's actually in the core types, but it's actually written into the APIs of using static Go code. It's not something that users can do themselves. Or maybe I want to create object with only a certain name. This is something actually you can do today. Or if you're a node agent, now that's kind of these LLM and GPU things are very hot these days. You have tons of node agents that run around and do stuff on the node's behalf, but you don't have a great way to kind of segment them. Or controllers could kind of do crazy things by kind of confusing other controllers that you also should prevent against. Or one of the examples from upstream Kubernetes is that there was this case where you could ask for a GPU. We're using a thing called resource claim, but there's actually a field in this which says admin access, right? So clearly you want to give people the ability, normal users should be able to access a GPU, but no one should be able to get root of the GPU, right? So, and this is just a field inside of, so like in this you would need something like a condition, like Lucas can create it, but only if admin access is false, right? So this was a thing that wasn't I went back and looked at the previous issues and stuff, and this is something that's been open for basically as long as Kubernetes has been around. So since RBAC was introduced, people asked for this, how can we solve this? But it wasn't actually clear how we would solve this problem. Because we, in the first, in the authorization phase where we don't have the object, we cannot just get the object. And why we cannot just get the object there is, if you give me a message and I don't trust you, but you tell me, please read everything within this message and don't run out of RAM, please. Or actually, please run out of RAM. And then only after I read everything you sent me, I would say, oh, actually, you weren't allowed to do this. But the damage is already done, right? That is one example of why we don't do it. And there's some other reasons as well. So it wasn't clear actually how to solve this. But the way that this can be solved is through a technique called partial evaluation, which might be familiar if you have been doing programming languages and stuff. So if you have an expression like this, which says that Lucas should be able to create gateways with only this certain class, where the class is a field on the object, you would have something like request verb is create, the API group is this, resource is this, user is Lucas, and all of these hold, then your Lucas is allowed to do it, right? And if I now do a kubectl create gateways, well, from the metadata alone, I know that the verb is create because this is, eminent in the HTTP request. So that I guess is true. Then I know it's a gateway, right? So these are also true. Now, I authenticated the user, Lucas. I know his name is Lucas, so that is true. And I know that this was a gateway v1 that was created, so this is also true. However, I don't actually know this thing, right? So I don't know whether a specific field on the object is true, or like whether it satisfies this invariant or not, because I didn't decode the object yet. So what if I just, but I know that if this expression ends up being true, then this whole original policy is actually satisfied, right? So I can actually just delay this evaluation. I just say that it seems like Lucas is most likely able to do this request, but I just keep this one condition and save it for later, and when I have the object later, I will make sure that this is true. If it's not, then I will reject it. So this actually satisfies the kind of, then using this unified policy, like, well, now it kind of, it wouldn't look maybe as messy as this, but this is pseudocode, but using one unified policy, you can actually express a policy across the both layers, and you don't have to think about when does Kubernetes do what inside of the API server. But one other way to think about it is also the negative case. So what I just said about denial of service attacks, if there's now a hacker that does exactly the same command, user is hacker, this is true, this is true, this is true, but the user is not Lucas, so this is false. Now actually, we see that no matter what this ends up being, this thing here below, this expression as a whole can never become true, right? Because you have false and something. So in this case, actually we can just deny it up front. We don't need to do the condition evaluation then later. So as said, today Kubernetes authorizer can say allow, deny, or no opinion. And if it's allow or deny, that's kind of clear. Then that either gives you a response code 200 or 403. Or then there's actually a chain, you can have multiple authorizers after each other. But this is basically the case in general. Now we add a new mode called conditional. And a condition can, well, it's basically a string that the authorizer says that, like, here is what Lucas should be, here are the predicates on the object, such as Lucas would be authorized, and whether that's an allow, deny, or no opinion rule. So what it looks like in aggregate is that you authenticate, you authorize, you ask the authorizer, it does this process, and from there it gives you allow, deny, or maybe, right? If it gives you a maybe, you take whatever conditions that was there, you save it for here, and then you enforce the conditions here. If they now turn out to be false, then you deny it, right? So through this method, actually, you don't need to do kind of two different languages, two different paradigms, three different objects. And actually, you might not even need to call out to the authorizer in the first place at all. So before we had like this, metadata is accessible through Kubernetes RBAC for both reads and writes. Then you had a mission, which is only for data and only for writes. And there was this other Kubernetes enhancement proposal, which is only for reads and only for data. So it's kind of messy. Like, do we actually need three different languages? Hopefully not. It's not clear yet, right? But hopefully not. So what could it look like? How could we express these kind of unified policies? So going back to this one, this is a big feat for anyone implementing access control. So, and that is kind of just the tip of the iceberg. Like, can user Lucas do X, right? Actually, you also might ask, what can Lucas do? Actually, I'm pretty interested, how far can I go? And not how far can I go in one step, but how far can I go transitively? So I do something, I get maybe more permissions. Then I do the next thing and keep on going. How far do I get? Actually, no one knows this today. So this is what I'm researching. And I have some interesting ideas, maybe I could share more soon. What I talked just about, block the kind of requests that we know are false, that are denied in the early, we deny them early without kind of decoding extra data or similar things. Or the other thing, you have a very, very sensitive resource. You want to make sure that no one can access it, only except a few people. How do you audit who has actual access to those things, right? It's not very clear in many cases. Or then, as you have tons of policies, how do you know that when you refactor them, they're actually equal, right? Do you ask an AI, which hallucinates the answer? Yes, because no one wants to read tons and tons of policies that are refactored. But what you can do is actually you can give this to old-fashioned AI, which is deterministic and actually works reliably. And it will give you a mathematical proof of that the thing is correct, right? Or do you have inconsistencies? We'll just talk about this. So the thing with CDAR, which I'll introduce here, is should everyone really need to build an access control engine themselves? Well, hopefully not. And there are a couple, obviously, access control engines out there, right? But I think my goal with this is to, see if there's a way that we actually could, in the same way Kubernetes, 10 years ago, moved everyone from you start with a VM, right? And now go figure distributed systems out, come back in 10 years and, do all of the things and then actually start focusing on our application. We moved from there to be like, okay, you got Kubernetes, you got some set of primitives, and now focus on your application. It's still hard, right? It's not, Kubernetes is still not easy, but it's a better place to start from compared to just getting a binary and start running it. So in the same way, I think that CDAR is interesting because in the same way it's like here's a bunch of if statements in your API server code. Start from there and make the iceberg, right? It's like, well, here you have an engine which implements a core of you for you, and then you can move from there. So with the risk of this classic one, what is CDAR? So CDAR is an open source authorization engine, and it supports both role, relation, and attribute-based access control. So that's already quite few that have all of them at once. It's rock solid. I had another talk about this. I don't have time to talk about it today, but you can. Actually before starting here, I was talking with Juan about deterministic simulation testing and property-based testing, and so hit me up anytime about this. But it's formally verified to actually be correct, right? And it comes out of AWS and has been donated to the CNCF. And I just kind of started as a maintainer there. So what does it give you? Well, a couple of easy things, but actually were pretty transformative for me at least. You have an IDE extension, so you actually, as you write your policy, actually it tells you here, okay, I'm writing a deployment, I can use, deployment.post is a boolean, right? And I know this directly. It's not that I have to do a GitOps deploy and CI/CD pipeline, and 5 to 10 minutes later it's rolled out and I realized I made a typo. Because if I make a typo, it will tell me directly, right? Before doing any of this. It can analyze using good old-fashioned AI, which is called satisfiability modular theories, or SAT, kind of an extension to SAT. Actually, that can you find something where that is within one of the areas, but not in the other, right? So, and if it can find something like that, then you know that you have a discrepancy, and you do that in both directions, and then you know if they're equal or not. So you turn into a policy search problem. Can you find a setting that violates my constraint? And if you cannot find anything that violates the constraints, then they are mathematically equal. Or you might want to do subset checking. So if you have a deny role that is bigger than an allow role, what is the allow one doing there? It's doing nothing, because denies are stronger. Or if you have two allow roles where one is bigger, strictly bigger than the other, maybe the bigger one was a mistake, or the smaller one was a mistake. Or you have a one that doesn't do anything, like an access control where you negate yourself in the policy. I managed to do that. And then CDAR is going to tell me that actually, that doesn't fly. And what I just said about who can access what. So if we have something like, I have this TLS secret that is really super secret, and I need to know everyone that has access to it. How can I know who has access to it? Well, if you have a policy like well, this is CDAR now, but using the same partial evaluation technique, you can say that, like I will mark the principal, so the resource owner or the human or agent or whatever, as unknown. So that I don't know about. But I will check that, like I know it's a write request. I'm interested in the write requests. I know it's a secret, so that's true. I don't know, again, so in blue here, I don't know whether this principal name is going to be Lucas, but I know it's a CLS secret, and I know it has type TLS. So I know because all of these other things are true, and it's and here all the way, I know that if the principal is a Kubernetes user, and that name is Lucas, this whole thing will be true, and then they will be permitted to write this secret, right? So yeah, that's how you can do it. So in August, I spent some time making a proof of concept for this. So express Kubernetes policies in CDAR. It's out on GitHub. You can check it out. It implements exactly what I showed on abstract before. So authorization phase hooks out to CDAR, checks your policies. Either you get allow or deny, or some condition. And if you get a condition, Kubernetes API server evaluates them in the second stage, but you don't have to think about that. You just write the policy once, and it spans the whole authorization space, and you can do the analysis that I just described. So for example, permit Lucas to create, update secrets when there's a specific type, or permit Lucas to list or watch existing secrets, so stored ones, where the predicate is the same, the type is the same. And now if I try to do that, so if I try to write first, I write some secret with the wrong type, I will get an error. And if I write it with the right type, that will be okay. And the same thing if I try to get secrets and without any selectors, it will tell me you're not allowed to do that. But if I get secrets but with the restriction of only seeing the type of secrets that I can see, then I will get that right list. So that's a little bit about the enhancement proposal in Kubernetes coming up. Join there's special interest groups in Kubernetes, talking about these things. We have bi-weekly meetings. They are unfortunately 9 p.m. finish time, so 9 to 10. So you can watch the YouTube recordings as well. But these review meeting for this proposal is at 5 p.m., which is a better time, although it happened to overlap with this meetup. The proposal is there. Hopefully, we could get it implemented in the next, or it's already implemented but reviewed and merged in the next cycle, which is 137. And well, the projects that I mentioned are out there. CDAR or the Kubernetes integration, all good. And on top of this, maybe we could build something, further down the road, like multiple years in Kubernetes time. We could build something inside of Kubernetes itself, not just experimentation out of tree. So yes, that's it. And thank you very much.
Any questions?
Yeah, does it work? Or otherwise I can. Yeah. Oh, stuff is just working now.
Yeah, thank you. So I wanted to know if this CDAR, policy execution language or whatever it is right now, does it have any kind of storage, external storage, where it could take data from, as, for example, OPA does?
So CDAR is, I didn't think I mentioned it today. It's a library. So it's a Rust library or a Go library, basically. So and that's kind of why I said it's the foundation, because it's so extensible that you can put it in basically any place, right? But it also means in the same way as Kubernetes is extensible, so you can put it maybe practically every place. You need to preserve an amount of kind of genericness, and can't be kind of have too many opinions about exactly how to do things. So there is no, for example, default, database or something like that. Modulo, there's a project that stores files on disk and stuff like that, right? But what you would do is most likely you already have a data store, most likely in your API, right? So then you would either store the CDAR policies in that same data store, where you anyways have your SQL and stuff like that, or you would have like more user, and actually this is what I would recommend, you have more user-friendly types of data in your data, in your database. So you would have stuff like, a table with, organization admins, right? And then you just have a table of organization admins like this, and then you wouldn't need to create the kind of lots of if statements of if it's in this table and if it's in that. Instead you kind of take that that data store and use it as a data store for CDAR with just one policy. Because when you use CDAR, you basically give it three things. You give it the policies, of which there could be, in this kind of org admin example, there would be only one policy, which just says that if the user is part of this organization and has this attribute, then it's allowed, right? But then, so you give it the policies, which could be fairly static, and then you give it the data. So like the users and how do the users, what groups are they in, what tags do they have, all of that kind of stuff. And that you would most likely have in your data store already, right? You have some representation of a user, etc. So you just give that to CDAR, and then you ask, is this specific user allowed to do this specific action in that context? So in that sense, it's very kind of embeddable. Yeah, like every application that's doing this will be most likely pretty different, right? So like no one will have exactly the same guarantees and kind of latency requirements. But yeah, there are some projects that are kind of building like on top of CDAR to kind of add more opinions and kind of add like here's a file-based storage, and people are doing SQL, so like the partial evaluation of like who can see what. I just talked to some people doing that kind of stuff as well. So like they're kind of is building a community around this open source project and kind of adding, but it's not part of kind of the CDAR core that you get for in the project itself.
Yeah, thank you.
Yeah.
Thank you for the presentation. You talked about access control policies, and you mentioned that like some policies can be redundant, some of them can be like conflict with each other or like include each other. It actually reminded me like the network policies. Actually, in the network policies also this is the case most of the time.
Yes.
And like also there's like another problem. There are like different CNIs and the custom resource definitions, so that is a bit hard to predict what will happen in the network policy. Like my question is that can your method like SMT solver can it be applied to create like reachability matrix or like to see the effects of the network policies on the existing systems?
Very good question. This is actually, well, the recording is on, but there's a couple of people at Aalto, me included, that are working on exactly this. Yes, in a research project at the moment.
Like, are there like any plans in Kubernetes maybe like standardize it somehow to like make it easier for people? I don't know.
Yeah, so like if the research in our group goes well, the goal is always to kind of, just like I did here, like starting from idea and kind of seeing how it could be applied, and then to, especially if you're patient, like the problem is you have to be really patient, right? Like you have to, like it takes multiple years to get anything in, and you have to commit for a long time and stuff like that. Given that we managed to first show that this works, like this SMT plus network policies, which I think it will, but I mean, before we have the final results, can't say decisively. But if it does, the best way and the way we would target is to actually, like do those corrections in the place where it makes sense in the ecosystem. So actually there is similar project also like from the same people that, like this started as a research thing and then has become, part of a, CNCF subproject somewhere in the Kubernetes world. So yes, that's a goal if it's successful and proven that it works and stuff.
Thank you very much.
So in between this one and then you go.
Thank you for the presentation. Very fast pace for somebody who hasn't been working with this for a while now. But well, good luck for the tests. And will the tests ever end towards the developer? In this case, you, for example. You have a thing going on that you think that this might be the correct answer, but you really don't know unless you get some really quality feedback from someone.
Yeah, so like I think that's kind of the stage that we're in at the moment as well, right? Like it's been presented at 2 KubeCons. There is, I don't know, like 20 something, like positive types of, like thumbs up and stuff like that. People on the or saying it would be useful, but more qualitative would definitely be nice and also quantitative.
Okay,
right.
A larger scale. I mean, human life cycle management perspective. Does one human ever get rid of these tests and start finally working on a project actually, or are there always these tests going on? Somebody gives you impossible platforms, for example. This is known to work in Google, for example, but in normal, like if you're a mortal, it's almost impossible to make it like foolproof.
Yeah, so these SMT things, they are very much known to work, and they are used in, well, especially in the bigger places. This partial evaluation thing also is used in many places. I don't know how much in this exact, like for this exact, like access control use case, but it's a technique used widely in other places. Yeah, I think user feedback is one of the main ones, and this is actually what I presented here. It's an intermediate step towards what I have here in the last one, like RBAC++. That is a thing that users actually will get excited about. And that's why it's hard to kind of do both the thing that we need to do to enable the final goal and kind of play with the final goal kind of at the same time.
Is the GUI?
No, it would probably be YAML, I guess, or something.
Okay.
It would be
who is the user?
An administrator that sets up, like access to your system. Yeah.
We will sweat no matter what.
Yes.
The one thing that came into mind was what was the perspective of the presentation that you gave? Because I thought that there was multiple perspectives and I couldn't follow because it's been a while. Or are you always inspecting from one perspective of, we have this scope of access. Let's say we have this control plane or something. And we are always control plane. Where does a control plane get direct access or API access? And there are multiple layers of security, for example. And it's not always just Kubernetes. There's somebody else in the world, except the control plane knows control plane, and there is no thing. There's God and control plane.
Yes.
Actually, control plane is God, but then there's something else also.
Yes, that is a good question, and that actually I left this for time constraints out, but I have another picture in some of the presentations where the goal actually of using something be general like CDAR, and it doesn't have to be CDAR. It could be something similar like a common expression language with some limitations and stuff. But I think what you would like to have is the ability to do partial evaluation, which common expression language does. The ability to compile down into SMT, some mathematical logic, which CDAR does, which no one else, to my knowledge, does. But Cell could do it for the most part. So but using something that is generic like this allows you to actually take a view way outside of the cluster as well, right? So like Kubernetes RBAC and the stuff that I showed is limited to just like I am the view of this cluster, I am a cluster administrator here, right? But actually, let's take a step back and say, well, now we have one language. Okay, maybe the language is good, maybe it's bad. But we have a language where we could express across different things and across personas and paradigms.
Almost every language is the same, but the thing is just the scope and what do you see? Well, is it clear that now that you are having a look at this point of the system, let's say that there is nice system that to be actually defined, it is definable a system, and you are here in the system, you are now looking at this point. This is something that is almost impossible for me in the past. And not only Kubernetes, but other systems as well. It's very, very difficult to see the right monitoring point and what actually happens. No, syntax doesn't matter what language we use. If you know one or two languages, it's fairly enough.
It's isomorphic, yeah. Yes, I mean, that's always, what your system is not the same as, what their system is. So, like, that's why I think it's interesting to take a look at the kind of foundations and what improvements you can do in the foundations to actually give you, as the system owner, a better time, right? I won't solve all your problems, I'm sorry. But if I can, if we can raise the bar to kind of give you the tools that would be useful for, using other things, and of course you need a combination of a lot of things, like if you need this type of, observability, what the policies do, but you need normal observability and you need normal defense in depth and IP based and whatever types of, like SSO security and things like this. So
just missing some dark matter-ish stuff in the between, but everything else is understood. Yeah, dark matter is very hard to define though.
Yeah,
it's so supposed to be no matter. Yeah. Thanks.
Yeah, so there won't be a silver bullet, but yeah. So you had a question as well, or no? Okay, yeah. Good.
Yeah, thank you.
Yeah, thanks for the questions, and yeah, see, let's have some more networking.
Yeah, let's have. Let's have a
That's very cool. Gateway is
I mean, the translation is down there.
yeah, try to understand without the translation.
Yeah. If there's any heavy metal fans, you would understand the fonts. And there's some fun games around. Like, is this a bunch of sticks or is this a heavy metal band logo? But yeah, I don't know. Is everybody here already? A bunch of people left, and that's fine. Maybe that's better. Do we start now? Yeah, are we good? Do you hear me okay?
Yes.
Cool. All right. Hey, everybody. So, joining the AI hype, I guess what we're going to do here is talk a little bit about LLM gateways, which is something that I started looking into recently, and I figured out the best way to really get deep into something is to give a talk about it, right? So, as it goes, right? So, pushed myself a little bit. But yeah, I mean, in case you know me or in case you don't, hey, my name is Juan Antonio Osorio. People call me Oz. And I work for a company called Stacklok, right? We're a former supply chain security company that pivoted into AI around January 2025. So we're now doing a bunch of that stuff. And yeah, I mean, I built a little project to spawn MCP servers securely because I'm still a security person by heart. In case you don't know what an MCP server is, it's the way to connect AI to external APIs, right? You know, a format or a protocol. So, but anyway, regardless, we do AI platform engineering, and what you should know about me, security. I used to do OpenStack, I used to do Kubernetes, I've done bare metal, right? So I'm a little bit like a fish out of the water in this new AI world, but it's been a good learning experience for me. And Mexican living in Finland. Right, so if you see the talk and if you hear the term LLM gateway, right, a lot of the things that you will think about is like, well, especially CNCF folks right here, you're gonna be thinking, it's the same old shit. Like, why are we revisiting this? Why are we doing some new stuff around this? And to most of the extent, you are right, except kinda, right? And that's like a rough awakening that I had when I started dealing with all of this stuff, right? Both in the MCP world, now in the LLM gateway piece, and going further, right, as we start digging into more of the nitty-gritty details of an agentic environment. It needs a couple of things. Part of it is cultural, right? And so it's kind of stupid to some extent. A lot of the folks dealing with AI nowadays are folks that have just done one piece of the application and not a lot of infra platform engineers yet. And so you see people making mistakes that we've solved all over again. So some of it is kind of cultural, and so that's why you keep seeing the same details. But to some extent, AI or agentic workloads are a little bit different. Like there is some nuances here and there that do make it a little bit more like a special snowflake to some extent, right? So we'll see a little bit of that. One of the things about my example number one about the cultural bit is input validation, right? Some of the first thing that as a security engineer, as a platform engineer is, am I securing, am I locking down, am I validating everything that comes from the user, which should be untrusted, right? And one of the most famous gateways out there who they're getting a lot of slack now from, well, not slack, sorry, a lot of heat now because of a supply chain compromise, had such an issue, right? Where an attacker could just inject headers and you could basically control the endpoint where you're sending up job tokens, API keys, even personal information, right? So like they've dealt with a lot of this stuff, but now it got even worse, right? But we're seeing this all over the place, right? Especially now that people are vibe coding applications. And I don't want to talk shit about vibe coders because nowadays I use Claude and I use OpenCode a lot, but like don't forget your basics. don't forget all of the things that we already learned. You gotta fucking do input validation, god damn it. And so many other things, right? So, not to talk, again, shit about it, but we're just gonna see a lot more and more. And some of those attacks are gonna become more sophisticated just for the reason that it's a juicy target. It's very, very, very juicy. And I think we are coming back to crypto miners running everywhere, right? I mean, crypto miners, you've seen them in CI, you've seen them in a Postgres database. Well, now everything's about tokens.
In the Kubernetes Tesla.
Yes. Oh God. But I mean, it's very similar, right? I mean, now people want to get a hold of provider keys. Now people want to be able to, as cheaply or for free, run anything in relation to AI because it's kind of expensive to some extent, right? But it is a juicy target. You know, it has user authentication. It has the provider keys that people want. It has cloud credentials, right? And in some cases, you could even exfiltrate what people are actually talking to the LLM, which might be completely sensitive information. It's basically a diary for some people. And so, again, really juicy, juicy, juicy target. As security engineers or as platform engineers, you gotta take that into account. Now, again, like some of the first thoughts, at least in my mind, that came is like, well, how different can it be from an API gateway and an LLM gateway, right? Like it should be very similar, and indeed it is, right? Some of it is the same, you know, it's an endpoint out in the cloud. It hopefully does security in such a way that first authentication, authorization, then you get OTel, then you get middleware, and so on and so forth, right? You're hopefully gonna see a very similar pipeline than the one that you saw in Lucas's talk, right? Like maybe there is some webhook support, maybe there is a couple more things in there, right? So some things are very similar with some nuances that I'm gonna get into, right? So on the client side, yes, it does terminate authentication, so it's kind of like a very similar thing. On the provider side, one of its main jobs really is to actually direct you to an LLM provider, right? And actually use or hold the API key or keys that allow you to actually get access to it, right? And in between, you know, you're gonna see a bunch of very similar middleware, almost the same stuff, except that now you care about budgets. Because again, like maybe now you're seeing a lot of news around people exhausting their AI budget in months as opposed to the whole year, right? Or sometimes you need to rewrite a prompt, sometimes you need to do PII, PCI redaction, right? Because you know, it's basically a journal to some extent, so it really matters. And those are the kind of like a little bit special snowflake middlewares that you're gonna see, and it's all kind of the same, right? You see all of the providers, you see a lot of the vendors out there, and it should hopefully be very similar, except for some things, right? And this is the things that caught me off guard. When you start getting into the details and on the wire protocol, in CNCF projects in general, you're very used to REST APIs, right? You're really used to stateless systems. You're very used to you trying to auto-scale and really be able to take advantage of the elasticity that the cloud gives you. You don't necessarily see the same thing in an AI workload, right? It's basically a full-blown SSE connection, right? And stateful the whole way, right? Like one pod gets killed, all of a sudden you lose completely the session and you start getting issues like in your editor, right? So it is very, very, very stateful and it's very big, right? You start seeing the JSON payloads like go back and forth and it's not REST. And so it's odd. It's something that took me by surprise. The second thing that took me by surprise as well is that all of a sudden tokens matter. And of course, once you start digging into it, it makes a lot of sense, right? And tokens is basically the measure of how the LLM views text, right? So when you're having a conversation with it, the first thing that it's going to do is tokenize it, and you get charged by the token, both input and output, right? So budgeting really, really makes a difference, and it's something that it's table stakes in a LLM gateway in general. And of course, like all of a sudden, your guardrails that are supposed to be fully deterministic are now probabilistic, which is crazy, right? Like, with a certain probability, the guardrails at some point are going to fail, and the LLM is going to delete your production database, right? If you actually give it access. So that's also something that took me by surprise, that I was a little bit shocked and still scared about to a big extent. But regardless, first principles, as a security engineer, as a platform engineer, like, don't panic. It's the same controls to some extent, and that's going to get you quite far, right? Basic HTTP, which headers do you care about? Are you stripping them all? Are you actually making sure that you don't trust anything fully validated, right? So that's one, right? Which decisions fail closed, right? Meaning, when a system, one of your controls fails, let's say your rate limiter, do you just let it pass or do you fail, right? Like, at some point you do want availability, but at some point you do want complete failure, right, of the request. And then which of the values that you're actually caring about are authoritative, meaning, for example, do I fully trust everything that's coming? Like, is it a job token? Then yeah, I fully, completely trust my IDP. I mean, because hopefully they have security controls in place. But am I trusting any other values? Like I said, some header or some part of the JSON request. Those are the things that you gotta think about. And yeah, I mean, like in any other gateway, going back to first principles, a lot of the issues are ordering issues, right? Like in any networking endeavor, a lot of it really just boils down to it being a pipeline of things. And that pipeline has to be in the right order, and you have to make assumptions at every state of your pipeline. And talking about pipelines, I mean, this is one example, right? CNCF, I'm a big fan of Envoy, right? I'm a big fan of many things. Like, Cedar is fucking awesome, Envoy is fucking awesome. And so while I was digging into this, I started looking at Envoy AI Gateway, which basically just takes Envoy Gateway, right, which is an gateway API, the successor of Ingress, right? And it just builds on top, and it adds all of the fancy AI features that you would want, right? So rightfully so, you get the client, it goes to authentication, right? And then it has a bunch of things that it adds, such as SSE parsing, right? Like quotas, budgeting, a bunch of features that you would expect from any LLM gateway. And then it goes up the pipeline, and you can inject whatever you want. Again, Envoy is a highly pluggable system. You can inject things via WASM, via gRPC, via even C++ if you're crazy enough. I mean, why not? In my case, I did xproc, which is external process, and it's just gRPC, that's all. So don't get too scared about that. And then goes up the pipeline, does some RBAC, right? Has rate limit capabilities if so you need, and then it routes to what it calls clusters, right? And a cluster is just the endpoint, right? Finally, you're able to add more injections into whatever is coming out of the LLM gateway, and finally it goes to the provider, right? And it really tries to narrow down my backends, my endpoints are LLM providers, because all of a sudden, providers don't speak the same. They kind of do, but kind of don't. A lot of them talk what they call OpenAI, which is just very specific JSON RPC kind of protocol, except that, again, it's not standardized because nobody talks about standards. And so there's small nuances that break absolutely everything. So yeah, that's the kind of thing that you have to deal with. So yeah, I mean, every filter that you saw in the previous one is a trust boundary to some extent. So again, just like putting it down concretely, any header that you don't strip or that you accidentally let pass is not authoritative, so you shouldn't trust it. If you put it in the wrong order, all of a sudden you might have the wrong principle that you're evaluating policy against. And it's all the same everywhere, right? So again, same controls for everything, same first principles, different domain to some extent. And I am masochistic or something, so I keep giving live demos. Before coming here, I think about an hour before, I just completely broke it because I was trying to change a little bit of the ordering and add a couple more things because I got excited with my with my external process. But I fixed it, and so now it works. And so let's give that a go, right? You're gonna see a script, but it's actually running against a kind cluster. And I don't want to type while I talk, and so the script types for me, but it's actually running live commands, right? But here we go, right? So one of the first things that I talk to is header validation, right? And why you should do it. And so let's go, right? First, we create our gateway, and this is something that if you do Kubernetes, you should understand, hopefully, and if not, I will explain it to you, right? A gateway class is basically just saying, for these things that are coming into my cluster, this is the type of gateway API that is going to resolve it, right? So after you have that, then you create a gateway, right? And the gateway is the instantiation of something that is going to listen into the network, that is going to get traffic from somewhere, right? Probably the external network. It could be something else, but yes, that's it. And in this case, it has some listeners, and it's going to listen in a particular port. Right. Created. Cool. AI backend. Here we go. Right. This is going to be a mock API, so you're not going to get some secrets off me this time. Maybe next time, folks. And so, yeah, now I want the backend to be OpenAI, and I want the AI service backend to speak OpenAI, right? So it's basically, first I tell Envoy to listen somewhere, like this is going to receive traffic, and then I tell the AI gateway, I want you to be able to parse this traffic, right, in the OpenAI format, right? That's basically it. And let's create a backend policy, right? So we're going to use this particular set of credentials in that policy. So it's going to forward with my API token that you saw, that is super secure, and of course it's in the screen. Creates it, right? A router. Yes, and so I want to be able to listen to a couple of tiers, right, that are going to take these headers, right? And I'm going to fully trust these headers. I have a premium tier, and if you set the model, it should be this one, and off we go, right? Job validation, that hopefully you know about, is authentication. So it's going to be using a fake provider and actually validate and give me some nice claims. Right. And this is the part that I think takes a bit longer. Here we go. Right. So we have a couple of JOTs that I pre-created, right? One for Bob and one for Alice, because, again, security textbook thing. And so, right, okay, now we're going to actually start doing requests. In this case, I'm not going to use a fancy AI client because I want you to see all of the headers and all of the fancy things. But normally you would use either Cloud Code or Codex or whatever. And so, yes, with a particular header, I want you to use GPT-4o Mini with the premium tier, which matches the security policy that I added. And that works, right? Unsurprisingly. Cool. Let's see. Now I'm going to be using a standard tier, and I'm going to try to use the premium tier model that I described. And cool. It didn't find it, actually. Oh, yeah, the tier was not there. And okay, Semales. There we go. Oh yeah, actually, now that I kind of messed up what I was trying to say. Actually, in the authorization policy that I gave in the JOT, Alice has a standard tier and Bob has the premium tier. And so here Alice is claiming, I have the premium tier, and the gateway just said, yeah, sure, why not? Because it just read the tier from the header, right? That's actually what happened. Sorry. I'm here, I get a bit nervous. Huh?
Do you have any tricks that I can use this premium tier for free because I'm poor and they seem to cost?
Yeah, I mean, apparently the trick is just set the header and it'll just accept it.
So it works.
It just works. And so one thing that I'm gonna do here that I can protect myself with is exactly what I told you, like remove things or add things. And in this case, I'm just gonna patch the tier myself, right? So I'm definitely taking use of that. There's actually better ways to do it. Normally what you wanna do is just set an allow policy for everything that you want, but I'm just showing you something real quick because I wanted to get something working in like a couple of days. Like, I don't know how long this took. Yeah, and I want you to get the tier from the job token, right? So I trust the IDP, it has all the information. So now go ahead and do that. And it's gonna replace my pipeline, start working. And now Kind is running. Come on, Kind, I believe in you. And this is why live demos can be dangerous, right? Because the cluster is converging. As you know, Kubernetes is eventually consistent. And so let's see how long it takes this time. Any questions so far? Sorry that it's going a bit messy. While Kind is rolling, I think it's like it's powered by a hamster.
It's very interesting demo, but I just one question regarding the common practice. So whenever you set up the listener, in most cases you should not use HTTP. You should always use HTTPS.
Yes, that's correct. No, this is a demo, right? And in general, and really rightly put, right? So Envoy gateway itself has the capability to add HTTPS in however you see fit, right? You either put your certificates in a Kubernetes secret that you just referenced, or there are ways to get something like Cert Manager to get secrets for you.
Yeah, exactly.
Right, so in this demo I didn't do it, but yes, it's possible, right? It's just a standard operation now in the gateway itself.
Okay, thank you.
Yeah, no, good question, yeah.
Inside system communication, do we need to use the S version or can we just use normal HTTP?
The LLM provider normally, I mean, any serious provider does require HTTP, right? And in the gateway itself, like it doesn't really matter. It's going to listen whatever you ask. In my case, like I said, just for demo purposes, this is like a local cluster in my machine. It does HTTP, but I could have set up HTTPS. I just didn't.
I formal question another way. Do you know a way to listen to somebody as a malicious actor, put a listener somewhere to listen for unencrypted system internal communication messages?
Yeah, many ways. I mean, but I mean, in this case, it's not going to be anything too different, right? It's just going to be standard traffic going out of the machine, and so. Like if you infiltrate the network, maybe you could listen over there. If you infiltrate the cluster itself, there are some places where it might go unencrypted, right? So not everybody's using a service mesh like something that Cilium would provide or something that Istio or something else. So inside of the cluster itself, there might be unencrypted traffic. So that's another juicy target right there. If you get access to the cluster, that is.
It's hard to understand. I remember this one.
Oh, sorry about that.
Okay.
But all right, in this case, now I set up a policy. I'm even trying the premium tier with Alice, and it fails, right? So now it didn't get it, and we should hopefully still see traffic still working for Bob. Let's see. Yeah, that still worked. Great. So first one, right? Do input validation, check the headers, everything matters there. Act 1. Act 2, PCI, right? A lot of people need this. Not every gateway gives that to you, so that's something that I had to do myself, right? So we're gonna recreate some of these pieces. Now I just support one model, right, to make it a little bit more simple, and that's gonna get created eventually, right? For this, I actually create a little gRPC project, right, that reads all the traffic, tries to check for some credit card details in several permutations, right, and redacts them, right, and that's it. I mean, it's not something that I would put in production, but it's something that is demoable, right, and now, again, kind is doing its thing.
Is this also using a local model or something to...
No, this
or
is
actually deterministic?
This is deterministic. But I mean, surprisingly though, like a lot of the state-of-the-art PCI or PII redaction systems are ML-based, but they are not LLM-based, right? It's classic ML, right? Like a colleague introduced me to Presidio by Microsoft, and that's quite used. That's one of the things that you would normally use in a production system, as opposed to some random guy just creating a gRPC system that listens to one particular set of patterns, right? I should get a beefier machine. I think it's time. All right, here we go. Now what I'm gonna try to do is tell the LLM like, hey, well, I mean, mock response PCI, right? I mean, there's a credit card number. I'm just have a mock LLM and I tell it what to answer. And in this case, it will answer because I haven't set up anything, right? It just has like a credit card like number and it responded. In this case, though, now I can show you a piece of the gRPC system. And it's not super fancy, like I said. It just scans a buffer, checks for numbers, redacts them, that's all, right? So nothing particularly fancy. PCI scanner, you can start adding them here. This is going to be super basic, so it's a service that allows access to the network, a deployment that holds my container with the PCI redactor, and an extension policy, meaning you can extend Envoy however you see fit, right? So I'm going to do that. Creates it, and now it's going to wait for the deployment to roll out, and this one is not too big, so, because it's Go, and Go is super fast.
Is it reading straight from some PCI port, or is it using a bus or something?
So the gRPC system from Envoy gives you network chunks. So from the response that it got...
where does it send a request for a response?
Okay, so the pipeline goes... you get the request from the Ingress, then it goes to the pipeline, and then at some point in the pipeline I have my extension. So it calls gRPC to my system, and then it returns.
Okay.
And it continues in the pipeline.
To abstract still, but it doesn't matter.
So, client is outside of the network, right? Goes to one set of the pipeline, goes to the next set of the pipeline, which is just translation pieces for HTTP traffic, and then here, what it really does is calls gRPC, which goes to my system, which is inside of the cluster. So it's just inter-cluster communication. I think I even set it in the same namespace, so it doesn't really leave that part either. Does that make a bit more sense?
A lot more.
Diagrams help.
Yes.
Okay, so let's give that a go. And I got a redaction, right, from the content of the data. It actually went ahead, detected that there was a credit card number, and it redacted it, right? So it went pretty fast, and it's because, Envoy fucking rules. Same, if I try to do something a bit more sneaky, like add spaces in between, it'll catch it, right? Or it will catch part of it. And then if I try to base64 decode it, it'll do it as well. Right, so there's all sorts of things that you can do, and this talk is more like a love letter to Envoy, more than anything. Thanks, Envoy folks. Yeah, I mean, you can do PCI redaction. And finally, rate limiting, right? So in this case, I'm going to use Valky, right? And you can see that I'm setting up a service for it. I'm setting up a little stateful set for the deployment, and that's it. Nothing fancy. Create. Oh, right, because that's a great question. Thank you. So one of the things is that, yes, while Envoy Gateway can itself do some of the rate limiting, normally what you want to do is keep track of the rate limits that everybody's hitting. Like if you're using something like a bucket algorithm, for example, you have a principal, which is your subject, and you put them in a bucket. And you're gonna say they have used this amount of quota, right? That's normally something that you wanna pull in somewhere stateful, and Valk is pretty good for that, right? Because it's really fast, and the replication between bulky instances is pretty fast as well. Yeah. So in this case, I'm doing that. Does that answer the question?
Yeah, thanks.
All right, cool. So AI gateway route, right? So again, like the same one that you saw, just one GPT-4o model, and created backend traffic policy, right? So now I start adding more things to it, and I'm gonna also use the model for bucketing, right? Basically, that's what I'm trying to do. And in this case, it gets a little bit funky, and that's something that probably we gotta try to fix upstream. In order to actually add fancier rate limits, you have to modify the gateway configuration itself, which is a little bit funky. And so I wish they would have a CRD for this kind of thing. But yeah, I mean, it's still V050, so it's not even version 1. It is what it is. All right, so now it configures it, and now it's gonna roll out the new gateway with the new configuration, and this takes a while. And again, it's kind of rolling around, chugging along, the hamster's running, off we go. Questions in between?
Okay.
Yeah, go.
Unrelated, but is the SSH bug real? Have you heard about it? Like 2 days ago. 15 years there's been a input validation problem, and
the GitHub one, or?
They found one now because somebody used it.
Yeah, no, I don't know. I mean, actually, you were telling me about it when we were stuck 40 minutes there below.
No, it's weird because you never know.
You never know. You never know. And I don't know.
Yeah.
All right. So now, gonna try to use that model, and it works for the first time. And then, like, again, that's a fail close kind of problem, right? If I kill Valky, will it just let me pass, or will it fail? And so now I'm gonna roll Valky down, and hopefully it doesn't let me pass, right? Because that's also one of the things that you gotta start trying. If my control systems go down, does it still let me in? And let's see. 500, right? So it didn't let me in, right? Like it's showing errors, and it actually tries to go through it, and it just fails, which is what exactly it should do. Now, if I go do it again, it starts scaling. Come on, Valky, you can do it. And it works, right? So that's it.
So it's fail closed.
Oh.
Right? If Valky is not running, so basically we can't send any traffic.
Exactly.
Okay.
And in some cases you want that, right? Like if my authorization server is it's failing, you want that. And so that's one of the things, like the takeaways as a platform engineer, which of your support systems should fail close and which should fail open.
Is it possible to change this behavior and then what?
In some cases, yes, right? In this particular one, if I remember correctly, no.
Okay.
Right.
Yeah, thanks.
All right, this is what I said before, demo, out of scope, right? And again, like more nuances about AI and things, right? What you saw were very classic attacks and the things that we can control, but then you get into the actual AI problems, right? Like, hey, is somebody trying to jailbreak and get access that they shouldn't have, right? Or is somebody using malicious characters to actually trigger the LLM to give them some funky information about another tenant, right? Or is somebody using the LLM as a guard, like the folks from Anthropic are, and can I trick it to give me access that it shouldn't give me, right? Which is auto mode from Cloud Code. Right, so there's a lot of things that are out of scope that definitely need a lot more, might be topics of other presentations, right? But yeah, I mean, you can do a lot, and I think the gateway is the right place to put a lot of the protections against these things. But again, like if there's a takeaway from all of this, we've done this before. Don't panic, folks. It's just audit your freaking gateways, right? Like that's the takeaway. Thank you, everybody. That's all. More questions?
Sure.
Lovely.
About the audits, something don't hit the filters that say that there's a bug or something. It's a feature, but the feature might be crappy.
Yeah.
And the configuration might be very difficult sometimes also. How does this, in the future for example, how do we know how to do things? Or is there an easy way to fix these problems, or are these just forever problems?
Yeah, I guess what you're asking is about, do we see a way to make administering these protections and systems in a more friendly way for somebody? To some extent.
That would be nice also.
Right. Or maybe I misunderstood the question.
Sometimes I feel, I forget what I was thinking, forget about it.
No, that's fine. And actually, like to some extent, if you're thinking about ease of administration and ease of use, this is somewhere where AI is actually kind of useful for. Like if you ask questions about documentation, for example, and you constrain it to a field or a model, it really does help you get information really fast, as opposed to you needing to go again and again through man pages, which is something that I've historically had to do. Right, so that's one of the good use cases for it.
Yeah, so you mentioned MCP at the beginning.
Yes.
And actually, you haven't shown any like streaming kind of requests.
No, I didn't. No, that's right.
Yeah, so does Envoy support that?
Yes, it does. So in this case, it was like a one-shot kind of request, which a lot of the systems allow you to do. But when you're establishing a session with an LLM, normally it's a persistent connection, like an SSE stream, right? And you're right, that's something that I didn't show. But again, what I wanted to do was show you the raw thing, right? Like headers and request formats, so on and so forth. But normally that would be what it does, and Envoy supports that very well.
Cool, thank you.
Yeah, and this was related to just the LLM traffic. For MCPs, it's kind of similar, but it's changing, right? So initially they started with SSE, then they switched to streaming HTTP, which is optionally SSE, and now the community is switching to fully stateless because, again, SSE traffic is really hard to scale. All right, any other questions? If not, I'll be around. Don't be a stranger, and thank you for listening.
Thank you. Maybe as a final thing, I'll just make it, or did you already tell about KCD?
We have the raffle.
Oh, yes.
I didn't find anything.
Giving free ticket to KCD, or was that?
No.
We could do that as well. Yes.
Just a spin.
The second prize is a free KCD ticket. Good idea.
So now we are having a raffle for this one. Kubernetes Go Rust sort of mastery bundle, which is worth 1,000 and is sponsored by Ardal Labs. And hopefully this goes well. Never did a raffle before.
Situation. I guess we could stop the stream.
I just